Hello and welcome to this video, Getting Started in VelPAK 2017. In this video we'll have a look at a few steps of the software VelPAK, which is the add-on module to the Kingdom software. And in this video we'll be having a look at data loading between Kingdom and VelPAK, then having a look at a few of the QC tools, and then having a look at a range of different functions for some depth conversion. Okay, so VelPAK loads with this relatively blank screen. So for us to begin, we can click on File, and then we can create a new model. Click on OK, and here we can write in our model name. Click Save. Our next task is to click on File, Open TKS from the Kingdom suite, and we have two options in Replace mode and Merge mode. So for this operation we're going to press Replace mode, and we can see that this loads the new data loading wizard. In here we can select the different types of data that will be brought into VelPAK, and we can select these discretely by clicking on the tick boxes like so, or we can click on the All button. I'll do this and press Next, and this takes us to the first of 6 screens, where in this screen we're going to have a look at loading the well information into the software. To do this we have the wells on the left hand side, and you can see that we're going to drag and drop them across into the well folder in the middle, and this will also bring across the tops information as well. In the central section you can see that whilst the data is loaded, we have the option on the right hand side for the preference and the well list options. If you have a look at the ticks in this section of the screen, you can see that we can work with sonic logs, then time depth chart as our preference, sonic logs only, time depth charts then sonics, and time depth charts only. And you'll see that the tick boxes update with your preference option. With the well list options we can group by well, we can group by curve name, group by curve type, or we can have no grouping. If we choose no grouping, we can select one of the column headers like so, and we can bring it up into this selection box in the middle here. And you can see that we have 19 wells with no association, 21 sonic logs, and 24 time depth charts. And if we click on any one of them, we can see which order we have selected as our preference option. From this position, we could say that we'll have a look through and we'll QC what wells we're bringing into the project, but I'll assume that this is correct, and I'm going to press Next and move forward. On the second screen here we can select the number of layers that we have in our model. So in so doing I have a 4-layer model, so I select 4 from the drop down menu, and this populates the central column with the 4-layer folder structure, and we can select the inline, crossline, or both in terms of the increment for the horizon settings, and specify that in this area here. What we're going to do in this process is take our time grids and put them in the correct folder, so grid time. And you'll see that the folders grey out, so they can only go in the correct location. So it's fairly foolproof for you. As I'm working through now and selecting the 4th grid, you'll see that the grid folder pops out, but time is greyed out. If I let go of the mouse button, you'll see that it comes up with a non-matching grid lattice message, and it says that it doesn't match the coordinates information for the first surface. A new surface can be made in the resampled surfaces folder, so we're going to press Yes. You'll see it takes a couple of moments to process, and then we have a new folder here, and we have this new resampled time grid for the 4th layer. I'll now select this and drop this in the time folder. In this part of the wizard we can also load fault sticks, polygons, and horizon data, but I'm going to move forward and just press Next. Now that we've defined what layers are in our model, we now need to associate the formation tops with them. So here I'm going to select the Upper Triassic, the Lower Triassic, the Base Triassic, and the base upper Permian. And what you can see as we look down here is that we have some of the wells having an issue in displaying their information, with this red flag saying that it's missing what formation top it needs to be associated with. Here I click on load, and you can see that the software will process, and we're actually going to create a series of graphs to show the formation settings. If you click on plot, it will now plot this graph for us, and this gives us an indication that we have the upper Triassic, the middle Triassic, and this formation top here called L-Trias. So I can see that I've missed this from the list, and if we bring this L-Trias top across, you can see that this corrects the issue here for us. So you can work through and you can QC your data in a similar manner. Again, to save some time, I'm just going to press next. On this screen we have the ability to bring in our 2D navigation and 3D geometry into VelPAK. We also have the option now to also bring in these seqY files. So if you've got them available, you simply select the option on the left hand side and drag it and drop it into the corresponding folder in the middle. Now VelPAK will load in 2D lines and 3D surveys, and we can do multiples of this as well for overlapping data sets. So you can just drag as many as you like into the central section and populate this to build your model. Here we've just got the one set of amplitudes, so I'm going to press next. And on this screen, which is the last of the screens to work with, here is where we use the seismic processing velocities. Now I don't have any coming in from Kingdom in this project, but you would select the volume and you would drag and drop them across. When you select this tick box, here you can choose whether those velocities are RMS velocities, interval velocities, average velocities, or none. And you can specify the time increment that they're decimated into, and you can select the spacing in map units. And this would be the real world units in feet or meters. In this project it's going to now represent 250 meters. Once you're happy with your selection, you can press next and click on apply. And you can see in the bottom right hand side that the data is being outputted from Kingdom and it's being imported into VelPAK. This process just takes a couple of moments to complete, and once the green bar has got to the end, you'll see that the data starts coming in and populating like so. At the bottom of the screen here you can see that this is finished, so we're just going to press exit, and we're now ready to work in VelPAK. When you get to this stage, you'll see that VelPAK sits and is fairly blank, waiting for you to make your first move. So one of the first things that you would want to do with your data is QC it. So let's have a look at the 3D module. VelPAK is very diverse and flexible, so it gives you the option to view the data in any way you like. So it starts with a blank screen. Here we can choose our layers to be selected as yes. We can overlay the surfaces with a double click here, and we can click apply. After a few moments, you'll see that the 4 time grids become available, and in moving this around, we can see that we have an issue with the third layer and the picking here. Now, the 3D viewer is just that. It's just giving you the information so that you can see what has come into the software. If this was to happen in your project, it would be the case that the interpreters had used the autoseeker in Kingdom, and as it got to the end of the line, it just pinged up through the horizon above. If you're to see this, the correction is that you'd go back into Kingdom, you'd correct the interpretation on the third layer, and then you would simply re-import that surface through the data loading wizard. Next we'll have a look at the wells. On the well display, if we click in the model tree and click on well, we can choose a well. And you can see that we're just looking at the uncalibrated well as it stands. If we click on the display flyout, we can change the display type from depth to time as an example and click apply. And let's say that we now want to calibrate this well. Before we do so, we can show the events as all, and we can click on apply. And this will now give us our 4 layers that are now color coded. If we click on calibrate, we can choose the type. So we're going to calibrate to the event. We're going to calibrate all wells, and we're going to work to event number 1 as our target to calibrate to. Once these are selected, we can click on apply, and you'll see that the well is now calibrated like so. Now in the well module, you can see that certain wells will have spikes in their data, and in the software we're in a position whereby we have the ability to clip certain spikes and remove them. In order to do this, we can click on the point edit, click on the log, and you'll see that it opens up a couple of editing options. And you'll see here is point insert, point delete, point move, and segment split. For point delete, you can click on the spike at the end, and you can simply clip this down. And you can see that this gives us very basic options for log editing. It would be of preference to go back into Kingdom and to correct this information in the Well Explorer module, and then you'd be able to get all of your logs conditioned in such a way that when they come into Kingdom they'll be despiked and ready to use for depth conversion. I'll assume that we've done that at this stage, and we'll move forward to actually having a look at the depth conversion through the wizard. In here I'm going to click on the wizard at the top, and we can see that we have our 4 layers and the ability to run a depth conversion function per layer. I'll select run for layer 1, and you'll see the wizard interface like so. The way the wizard is designed is that we have the different depth conversion methods on the left hand side, and we have the help screen in the central section, and the ability to press previous and next in the bottom right. Now if we have a look at the well module, we can see that we have an increasing trend with depth, so our velocities are getting faster, so we could use something like the optimize technique for this sort of problem. I'll select next, and next again. And here we can see that we have different functions to be optimized. I'm working from the seismic datum, from the seabed or other arbitrary datum, or we can work with uplift from base. Here we can optimize to fit to the well curves, or to minimize the residual tie with the well formation tops. I'll fit to the well curves because the data is fairly sparse in our survey area, and I'll press next. The software defaults the parameters for the optimize automatically, so I'll just click on run optimize, and we'll see in the bottom middle of the screen the software processing, and it takes a couple of moments to do so. As this is running, you'll see the information working in the console window, and in a few moments we're ready to have a look at the optimized screen. What the optimized screen is showing is the V0 and K pairs for our wells to give the best fit to all of the wells, and the single value of V0 and K in the center of the solution trough will be our parameters for K and V0, which are applied to give minimal residuals at all our well locations. We can see that we have good convergence with this dataset, and we can, for example, choose the display flyout, and we can choose the line fit, and we can click apply. And you can see that the optimum value of V0 and K for each well is formed in this space, with the optimum V0 and K satisfying all of the wells being at the center of the solution trough. Once you've run the optimize, if you click back on the wizard, you can see that these parameters are noted here. and we'll press next to confirm. With K being a constant in a formation, and now that we can see in the bottom of the wizard here that we know this and it's fixed, we can do the option whereby we can fix K and contour the V0 values. And again, we can minimize the residual depth or the fit error. So here I'll work with the residual depth. I can choose a kriging range of, say, 2000 meters, and we can generate the V0 grid and display it. You can see as this processes that in a few moments it will be ready to view. On the surface display here, we can have a look at the map that's generated, and we can see the interval velocity values at each of the well locations. If we're happy with this, we can click on the wizard and we can click on next, and we can pass through now the options for the volumetrics and the save file options, which would be used for the multiple realizations. So when we click on next again, we have completed a depth conversion for layer 1 using the optimize function. If we click on the surface tab at the top here, you can see that with the fixed K and contouring of V0, that our residuals in our wells have been corrected and are almost zero. So we could use this as our technique for the first layer. If we click on the wizard again, we can now run a depth conversion for layer 2. Here we can click on run, and we could in this time select the curve module, which is our graphing module, and press next like so. Next again, and we have the options here that are available. Now you'll see that the average velocity versus time to base of layer function is grayed out for subsequent layers after layer 1, and this would mean that it would be pointless to have considered the first layer in running the average velocity down to layer 2. So this is not available for us. Instead, I'm going to have a look at computing the interval velocity versus depth to middle of layer. And on the graph here, we can click on show labels, and we can generate the function. If we click on the curve tab, we can see the regression that's drawn through our data points, with the regression parameters noted at the bottom right hand side of the graph. One of the strengths of the software is that we can detach some of these headers by holding down the option. We can have a look at the surface display, for example, and the well, and we can drag these into position like so. We can really get a handle on what our data may be trying to tell us, so we can, for example, select point pick, and we can investigate why some of these data points may be outliers. And we have the option to turn them on and off if we see that there's a problem with them. So for example, in this instance, we could select the point edit, turn off this well, and we see that that is located in this part of the survey area. Once we're happy with this selection and we've worked through all of our data, I'll assume that it's correct from the purposes of this video, we can click on wizard and we can click on next. And we have the option for error correction. Here I'll just remove these flyouts by double clicking on the tabs and double clicking again. And we could do an error correction for this layer, or we could leave it so that the error correction is not computed. I'll select the error correction on in this instance, and here we can specify the kriging range. So again, I'll choose something like 2000 meters and click on generate error correction grid. You'll see that it takes a few seconds to process once more, and we just have to wait for it to complete its task, and then we can view the error correction grid on the surface tab. If we have a look on the error correction grid here, we can see the residuals at the well locations and the error correction applied away from them. If I click back on the wizard, we can click on next, Next again, as we'll not be looking at the multiple realization options in this video, and we can now do a depth conversion for the third layer. On this layer, what we'll do is we'll have a look at some of the seismic velocity options. So I'll choose seismic velocity and press next. And you can see that the data has not been loaded, as I didn't do this in the first step. What we can do is press previous, and we can load the data manually. If I go to File, Import, and Profile Stack, and we click on the little dot button here, if we click on the data folder, you'll see that I have ASCII velocities in this file. If you locate your velocities and click on Open, the next important step is click on the prefix and choose the velocity header for the import. Once you've chosen this, when you click OK, they will load into the data, and if you click on Run and on Next, you'll see that we now have the velocity information loaded. I can click on Next again, and for this option, what we'll have a look at doing is calibrating to the wells and depth converting. I'll press Next. And you can see again it's just processing the information at the bottom of the screen until we're ready to go. Okay, so we have a couple of smoothing options available to us. We have the simple moving average smoothing, and here we can choose a smoothing radius. Let's specify this to be, say, 2,000 meters once more, and apply this just to see what the implication is. If you click on the surface module, you can see that the grid has been smoothed, but we have some issues over in this location. I'll click on the advanced multipass smoothing using local regression, or LOES as our nickname, and we can select apply local regression smoothing. With this gridding algorithm, it takes a little longer to run than the simple moving average smoother, so it just requires a bit of patience as it calculates. For the purposes of this video, I'll just skip through the 40 seconds while it does this. Okay, so that's just processed now, and we can have a look on the surface display and we can see the gridding that's been computed. Now that we're happy with this grid, we can click back on the wizard and we can press Next. Here we're looking at applying a calibration factor. So if I click on the curve display, here we're looking at applying a calibration factor. So we can click on Apply Calibration Factor, and this will apply the calibration factor to the seismic velocities. We can then press Next. We're able to generate an error correction grid again, so again I'll choose 2000 meters and click on Generate Error Correction Grid. Again, this takes a few moments to process, and we can view the error correction grid once it's completed in the Surface tab. Okay, so we can see the error correction grid on the surface display again, and I'm going to click on the wizard and press Next. Next, 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 and we're almost done for our 4-layer depth conversion. For the 4th layer, I'm also going to use the seismic velocities, but this time I'm going to do a 2-step process whereby I'm going to Dix convert and use the stacking velocities and generate an interval velocity grid with no depth conversion. So I'll select Next, and on this screen we have the ability to run the smoothing option. So again, I'll click on Apply Local Regression Smoothing, and I'll just skip through the video just to save you some viewing time. Okay, so now that that's run after a minute, we can click on the surface display to see the gridding that's been completed, and as we're happy with that, we can click back on the wizard and we can press next and next again. Now that was stage 1. If we click on run again and seismic velocity, what we've done there is created our interval velocity grid with no depth conversion. What we're able to do now is use that drift grid, and if we click on mapping and next and press next again, we can now map the vertical apparent interval velocities and use that drift grid as an external drift surface. I'll select kriging for the sparse data that we have available and press next, and then we have the option for our kriging range. Here I'll click on the use kriging with external drift option, and we'll choose the drift grid that we've just created, which is stack interval velocity smooth and is located here. Here I'll click on generate grid, and again I'll pause the video and come back to you once it's completed processing in about a minute. Okay, so now that that's finished processing, we'll click on next again, and next again, as we'll not concern ourselves with the multiple realization options. Click on next, and we now have completed our 4-layer best technical case. Now in reality, you would try a different number of combinations of different functions, and you would determine the best parameter set per layer. Here I've already done this and chosen these as the best fit for the data. If we click on the surface module, you can see that we have our final depth grid with the depth from map well vertical apparent interval velocity for event 4, layer 4. And this would be the end result that we would get to. If you have any further questions regarding the software, then please contact us on support@equipoisesoftware.com or on the number below if you wish to speak to us during normal office hours in London, 9 AM till 5 PM Monday to Friday. We hope you enjoyed the video and look forward to hearing from you.